Well, hello, and welcome to the webinar today. My name is Carrie Berger, and I'm the coordinator for the Northwest Fire Science Consortium. As I'm sure you've heard me say before, if you've been on our webinars, the Northwest Fire Science Consortium is part of a 15-member collaborative network of fire science exchanges funded by the Joint Fire Science Program. Each exchange is working to communicate fire science within their regions and working across regions to share best practices. To learn more about the Northwest Fire Science Consortium and the Exchange Network, visit our webpage at northwestfirescience.org. So to avoid any noise interference, I have muted your audio, so if you have a question, please type it into the chat box. Also, I will be recording the webinar and will archive it on our website and YouTube channel. Today's webinar is the 9th webinar that we've hosted this season alone. Webinars have covered risk, prescribed fire, weather, and much more. If you haven't already been on our YouTube channel, you should consider checking it out. You can find both our web address, our website address, and the YouTube address in the chat window. So it's my pleasure to introduce to you today both Jim Smith and Corey Blankenship. Jim Smith, TNC LANDFIRE Program Lead, joined the Nature Conservancy in 2004 to helm the brand new LANDFIRE project. Prior to TNC, Jim was on the forestry faculty at Virginia Tech, headed Forest Information Systems Development for Champion International Paper Company, and worked in the commercial sector. His research has appeared in fire ecology, forest science, photogrammetric engineering, and remote sensing, Canadian Journal of Forest Research, and the Canadian Journal of Remote Sensing. Jim earned a bachelor's in timber management and a master's in forest biometrics from the University of Georgia, and a PhD in forest biometrics and remote sensing from Virginia Tech. Fire ecology Corey Blankenship joined the Nature Conservancy LANDFIRE team in 2005. During her tenure with the Conservancy, she has facilitated the development of hundreds of ecological models, pioneered methods to estimate the historical range of variability, and applied LANDFIRE products to address land management challenges around the U.S. Corey earned her bachelor's and master's in geography at Western Washington University. She also holds an incident qualification card, or as we call them, red cards, and is frequently seen carrying a drip torch on prescribed fire lines. So Jim and Corey, welcome. You can begin whenever you're ready.
Hello, everyone. Can you hear me, Carrie?
I sure can.
Okay, great.
Looks good.
Well, first of all, Corey and I, on behalf of the TNC LANDFIRE team and the entire LANDFIRE program, really thank you, Carrie, and the Northwest Fire Science Consortium for the opportunity to participate in this webinar today. And we also thank all the participants who are using their valuable time to listen to our presentation today. So we feel like it's a privilege, and we hope we use it well, and hope you find this information useful. So the agenda today is going to be talk a bit about the past. It does impact what we're doing today, the present, the future. Then I'm going to turn the presentation over to Corey, a Northwest native, to talk about the impacts in the Northwest. Talk something about the review of the biophysical settings, models, and descriptions, and then to help those trying to use the LANDFIRE program products. So who is LANDFIRE? Well, it's important to understand that it's a partnership between the Office of Wildland Fire, Department of the Interior, the Fire and Aviation Management Branch of the U.S. Forest Service, and the Nature Conservancy. This team has been together for almost 15 years now. On the left, you will see the core of the production staff who are housed in the USGS Aeros Data Center in South Dakota. And on the right, you'll see the TNC LANDFIRE team. And I'll introduce them for you. That's Corey Blankenship on the left there, Bend, Oregon. Myself, the program lead in Jacksonville, Florida. Jeannie Patton in Boulder, Colorado. Sarah Hagan, spatial analyst in Minneapolis, Minnesota. Randy Swati, an ecologist in Marquette, Michigan, and Kim Hall, climate scientist in Lansing, Michigan. So these are the core people who make up the LANDFIRE team. And our role as the Nature Conservancy is primarily as ecological subject matter experts to support mapping and to support users. We have created the state and transition models that LANDFIRE uses, but also we are leaders in communication such as happening today, outreach, working with users and supporting them. So we hope that you will call us should you have any needs, have any questions, work through the help desk with LANDFIRE or through one of us if that's the best way to get the help that you need. So talk about the past. The LANDFIRE has been around for 15 years. We began with a charter that was quite a long document, but really I boil it down to the design criteria for the products that we create. And there are quite a few, but I think there are 4 critical ones, and I call them the 4 C's. That LANDFIRE must be comprehensive. That is, cover every acre of the continental U.S., Alaska, Hawaii, and eventually added the insular island territories such as Samoa and Puerto Rico. So comprehensive, every acre. Compatible. All the products need to match each other thematically as well as geometrically so that they are usable basically from the very moment that you download them. You should have to do little or no processing to utilize them. That's the compatibility criteria. Consistent. We have done everything possible to hold methods, data sets, processes, products as consistent as possible through time and across space to allow comparisons. That is a critical use of these particular products, is comparisons. Now, in the spirit of improving products, we have not been entirely consistent from day one to today. We are not really 100% consistent across the country because Samoa is really quite different than Maine, but we ask ourselves the question all the time, can we be as consistent as possible to allow comparisons? So that is an important factor that we consider whenever we're making a decision. And then finally, the product should be as current as possible. And the 3 C's above certainly impact how often we can produce and deliver these products. But it is a design criteria that we make the products available as soon as possible, keep them as current as possible. These 4 C's have a tangible impact on what we can deliver, when we can deliver them, and how well they represent the conditions that you see on a day-to-day basis. So please keep these design constraints in mind as you use LANDFIRE products. LANDFIRE product suite is composed of 20 to 25 current and historic vegetation fuels and ecological condition spatial data layers delivered at 30-meter spatial resolution. There are 800 plus quantitative state and transition models and descriptions of what we call biophysical settings or historical vegetation patterns. That's the primary suite of products of LANDFIRE, although there are some things in the background like the LANDFIRE Total Fuel Change Tool, which is a product that we will deliver and support the people who need it. LANDFIRE has delivered 5 versions. The original version created at the start of the program representing conditions circa 2000-2001. We call that LANDFIRE National or LANDFIRE Improved. And then we updated that product 4 times, 2008, 10, 12, and 14. But we're now engaged in what we call Remap 2016. Before I talk about Remap, I just wanted to give you an idea of the breadth and scope of the program products. And I expect no one to read this. This table is available on the LANDFIRE website. It's not hard to find. But if you look at this, you'll understand what the program has accomplished. The rows in this table represent the different products. The columns, beginning with LANDFIRE 2001, represent the 5 different delivered versions. And then the sixth column, the final column on the right, does represent the LANDFIRE Remap. And the blue text in the table represents the geographic segments that have been delivered. So you can see it's a lot of products, many different versions. It is quite deep and broad what LANDFIRE has delivered. But now we're engaged in a remap. We divided the country into the continental U.S. into 6 different areas. The Northwest geo area is what you see here, the one of major interest today. We delivered the products, the vegetation products, the existing vegetation type, existing vegetation cover, existing vegetation height, as well as the surface fuels and the canopy fuels for this area back a month or 2 ago, made them available for download on the LANDFIRE website. And what you're seeing here is the LANDFIRE existing vegetation type. The remaining products, the fire regime products, won't be delivered until the end of CONUS, about a year from now. Those will be done nationally all at one time. So do not expect to see the fire regime products until next summer. So in a remap, which is important to understand that remap is a recreation from scratch of the products. It is not an update like 8, 10, 12, and 14 were. It's a recreation of the basic data set. What remains the same in this recreation? Well, we still have the same design criteria. We have the same constraints. We need to be comprehensive, compatible, consistent, and current. And really, the basic framework of the products is the same. The product suite is very, very similar, but there have been changes to some of the underlying processes and to the thematic content that are intended to improve the usability of the product. So the basic structure will look the same, but you're going to see some different things within the products themselves. Corey is going to be able to illustrate a bit of that for you when she does her portion of the presentation. But the fact that LANDFIRE is still a large landscape, regional, national data set as delivered out of the box has not changed. That is still the delivered application scale for LANDFIRE products. So you think large landscape, regional, national data set. If you want to use it for smaller geographies, it needs to be reviewed. It likely will need some sort of modifications in order to be relevant for smaller geographies. That is still the same. So I'm going to list a few of the enhancements or changes to process or products in the next couple of slides. I'm not going to go into a lot of detail, but I want you to understand that a lot of things have changed, and we have done all these basically in the spirit of improving the usability of the products. So we used to use NLCD map zones as the geographic framework for our mapping process as well. Now we use something called Omernic Level 3 ecoregions, which are much more ecologically differentiated, ecologically relevant than NLCD map zones. So that helps us with the seam line issues and some of the other things that we've run into in the past. We have new image processing methods on the base imagery that we utilize, such as compositing, that is merging different images together, how we tile them, how we mask them for clouds, etc., shadows, that we think has provided an improved and more consistent imagery base from which to do the mapping that we create. We have new and improved auto keys. An auto key is we use to assign a vegetation type to the hundreds of thousands or maybe even close to 1 million plots that we have in our plot database. So we use this auto key to assign those vegetation types to that. We had some problems with the auto key in the original version of LANDFIRE, but we spent considerable amount of time over the past few years improving those auto keys to get better plot assignments. We now have available to us Landsat 8 imagery, which is improved over 5 and 7, which is what we used in the past. And we also have available to us things called Landsat analysis ready data sets, which are more extensive image stacks that we can use in the mapping processes. An important inclusion this cycle was to allow time for internal and external review of the vegetation legend that we're going to map, as well as the draft products, which allowed us to make changes during the actual process, and we think create a better product. And again, Corey is going to give a little bit of an example of that in a moment. A new product, sort of new, is that we now independently map NVC group. That's the National Vegetation Classification, the de facto standard classification for federal mapping. We do now independently map group instead of crosswalking it from our mapped ecological systems. So we provided group before, but as a crosswalk, now we independently map it. We have many, many more field plots available to us now in this version of the mapping process than we had originally. Not only because of the time that has gone by, it's allowed us to accumulate more plots, but also because we worked on agreements with other agencies and groups to get more types of plots. For instance, the Bureau of Land Management Assessment, Inventory, and Monitoring plot database, really heavy in the shrublands, that is now available to us. The Natural Resource and Conservation Service, NRCS, Natural Resource Inventory plots, which are much more heavily weighted toward private land, agricultural land, they are now available to us. So we have a much more broad-based set of field plots on which to base the maps. An important innovation in this particular version of LANDFIRE will be the incorporation of LIDAR data sets. Now, we don't have LIDAR for every acre in the country, so we incorporated the LIDAR data sets that we could get into a modeling process, and we use that to improve the thematic resolution of the structure products, particularly the height, and Corey is going to show you that maybe in her part of the presentation. It's allowing us to do a lot more finer resolution mapping than we could do in the past on the structure components. We were involved with the National Land Cover Database program on their continuous shrub cover mapping project, which again, we can now incorporate what they learned and the products that they have into the LANDFIRE processes, which should help us improve the cover products, especially in the shrublands. We also, in the last 3 or 4 years, underwent an extensive review of the biophysical settings models and descriptions, which are available now upon request. Corey is going to give an example of that in the Northwest as well. So this product has now been streamlined and we believe improved quite significantly. There are also some new products. Besides the NVC group being independently mapped, there are some changes to the fuels products that those of you that use the fuel data sets are going to find quite useful, such as the incorporation of historic disturbance rather than just the last disturbance, the most recent disturbance. We have the data sets for vegetation type that's also included that will allow you to use the LANDFIRE Total Fuels Change tool, etc. So these are now available to you, specifically created to support the fuel mapping process. And just so you know, we've also recently made some changes to how the fuel products will be delivered, what they're going to represent on the ground. I'm not going to go into detail on that, but that will be coming out soon, and it will require us to re-deliver the Northwest fuel. So those of you that have downloaded that fuels set from the Northwest, there will be some changes coming that you'll want to be mindful of, but we think that you'll find them very useful. And finally, we are implementing a new backwardly compatible fire regime group schema. That has been one complaint in the past. Even though LANDFIRE didn't develop the fire regime group schema, we did produce some of the first national maps of fire regime group, and people found it lacking in terms of usability and fire planning. So we undertook a project with Wendell Hand and used that to develop a new schema for fire regime group, which basically subdivides the old 5-category system you see in the left-hand column and creates some subcategories within each that give us more thematic resolution in terms of fire return interval. So instead of fire regime group 1 being 0 to 35, now it's 0 to 5, 6 to 15, 16 to 35, and we think that's going to be very useful. Remember that this is a fire regime product, will not be delivered until CONUS is completed about a year from now. So let's talk about quality. So we were able to basically simultaneously deliver the assessment of the vegetation type layers with the data itself when it was made available to the public. We also made the assessment available. We provide assessments for ecological systems, which is directly mapped, for NVC group, which is directly mapped, for NVC macro group, which is basically a roll-up in the NVC hierarchy from group to macro group, and then also an assessment of the SAF SRM cover type. That is still a crosswalk from the ecological systems, but assessments are available for all 4 of those particular classifications. We had somewhere more than 9,000 plots in the Northwest that were not used in the mapping process, so they are an independent plot against which we could test the quality of these particular classifications. We deliver a traditional contingency table, which I'm going to show you. We deliver a category agreement table, and a new delivery this year is we provide an example of how you collapse categories in a contingency table should you not use the native classification scheme. So for instance, if you lump categories in some instance, maybe you only want 2 or 3 ponderosa pines instead of all the ones that we deliver, or you want to lump all conifer, or whatever you want to do for your particular situation. We provide an example in there to show you how to collapse the contingency table so that you now have an independent assessment of the particular classification that you're actually using. We have found that it's very common that people don't use the classification as delivered. They collapse categories as needed for their particular purposes. We are also working on an assessment of the vegetation cover and vegetation height layers, but we didn't have one available when we started, so we're developing that process now. We will certainly make it known when that is available for review and download. So this is what a contingency table looks like. Typical rows represent LANDFIRE mapped pixels. Columns represent plot assignments across tabulation. What did LANDFIRE say this pixel was versus what the plot within that pixel said it was? And then you just tabulate. The major diagonal there indicated in yellow indicates agreements. Anything not on the major diagonal we might call a mapping error or a disagreement. Very typical way to present the results of a categorical map and to illustrate its quality, its accuracy. The problem is LANDFIRE mapped 169 different ecological systems in the Northwest. So the contingency table looks like this. That's not even all of it. That's just most of it. That's very hard to interpret, very hard to use. So we created this category agreement table where each category that had a sufficient number of plots has a record in this table, and it's based on the rows of the contingency table, and it shows you the ecological system, how many independent plots were used to assess that particular type, how much of the independent data set it was, sort of a proxy for how much it occurs on the landscape. And then what's the agreement? So if you look at the first one, Northwestern Great Plains, Black Hills, Ponderosa Pine, Woodland, Savanna, 359 plots, % of those, LANDFIRE called that same ecological system. Importantly, the next 3 columns really tell you the meat of the matter. What were the disagreements for that type? So that tells you whether or not you think that type is sufficiently mapped for your purposes. And only you can tell that. I can't tell that for you. LANDFIRE program can't tell that for you. So if you look down 3 or 4 rows to North Pacific seasonal Sitka spruce. So you see its agreement, LANDFIRE was 68%. But you see the kinds of errors that LANDFIRE made. North Pacific, Maritime, Mesic, Wet Douglas Fir, Western Hemlock. Maybe that's important to you. Maybe it's not. So we provide this table so that you can discern how usable this data is for you. We can't make that decision for you. The last column you'll see on the right also indicates what the data source is for that particular type, because we did incorporate other data such as ag data from the National Agricultural Statistical Service, etc. And if we got that from somewhere else, we tried to indicate it in this table. So hopefully there's a lot of information here that will allow you to assess the usability of the products. So what's next? Well, budgets are definitely a problem. They're difficult to predict. They're going to impact what we can deliver and when we can deliver it. We don't know what's going to happen in the future, but our plan is certainly, and we believe we're okay in this vein, to complete CONUS within about a year. And that includes the fire regime products as well as all the base vegetation and fuels products. But during that year, we're going to have to assess what order and what priority there is for Alaska, Hawaii, and the island territories, because that could end up being a budget decision. We want to do it all. We hope that we can, but we're certainly going to deliver CONUS within a year. So Remap 2016 for the continental U.S. will be complete within a year. Our next delivery is in less than a month for the Southwest. Then about 3 months after that will be South Central. 3 months after that will be North Central, etc., across the country. Because remapping is more expensive than updating, who knows if and when we're going to be able to conduct another remap. That's what makes the updating process very important, and we're working really hard to try to create an effective updating process that provides products rapidly when needed, but then also completely and thoroughly when needed. So this is taking some developmental work, and we think we're making progress on this, with the goal being to provide products that are on time, that have little lag time, that are of the right vintage, that then can be used quite easily for operational planning, either whether it's conservation or fire, natural resource management, or whatever. So we are working hard on creating a new and effective updating process. So that is it for me. I'm going to turn it over to Corey now.
Well, hello, everyone. Get the PowerPoint switched over. Carrie, how's my volume?
Sounds really good, Corey.
Great. I've got a little thing from the webinar on my screen. Can you see that, or are you just seeing my slide?
I'm just seeing your slide.
Okay, perfect.
Okay, great.
Great. Well, Jim provided an excellent broad overview of the Remap products, and I'm going to dive in with some specific highlights from the Northwest. I've got two examples of how I think existing vegetation type has been improved. There are a lot of examples we could have chosen from, but I've chosen two, and the first one is for this Palouse prairie system. So this is a very rare type on the landscape, but it's important for conservation. In LANDFIRE 2014, we mapped this type all over the Columbia ecoregion, Columbia Plateau ecoregion, as you can see on the left side of your screen, and actually even beyond that ecoregion in some cases. Now in 2016, in the remap, as Jim mentioned, we tried to constrain types to Armornic ecoregions when appropriate, and that helps contain them within geographic areas where we would expect them to be found. So in this case, the Palouse prairie was restricted to the eastern portion of the Columbia Plateau ecoregion, and then the mappers went in and sort of fine-tuned that distribution using gap land cover data and some other methods. Another example of how this plays out on the landscape for more widespread types, you can see here in LANDFIRE 2014, we mapped California, Mediterranean, and Sierra Nevada vegetation types all the way up to the Columbia River. Now, using the ecoregions to constrain the distributions of these types more heavily, in Remap 2016, you can see on the right that we've restricted them to Southwest Oregon. Jim mentioned that we are mapping height and cover continuously now. This is just a sample of what these legends look like. You've got height on the left and cover on the right. The legends are too big to display here, so these aren't even complete legends. It's just a sample. Now, in the past, we've delivered binned data or classified data. So the cover was in 10% bins and height varied, but I think we had 5 or 6 classes for forest, 4 for shrub, and maybe 3 or 4 for herbs. So there's a lot more detail here. Now, I wouldn't necessarily recommend using the data, say at the 1 meter height level or the 1% cover level, but what this continuous legend gives you is the ability to create classes that work for you. You don't have to use LANDFIRE's classes. You can create height classes that work for you and your landscape. Zooming in a little bit, you can see the difference between a classified cover product, in this case on the left, and the continuous cover product on the right. So this is existing vegetation cover data, and in the LANDFIRE 2014 product, you can see the whole sort of upper half of this image is one color. It's that tan color, and that represents one cover class. On the right, you can see all this fine-scaled variation, and so you get a lot more resolution in your continuous canopy cover data. There are a few new fuel data sets that are going to be delivered, that already have been delivered for the Northwest, and these are fuel vegetation type, cover, and height. These layers represent a pre-disturbance vegetation condition, and they're designed for creating the fuel products. Now, for users, what that means is if you're going to locally calibrate your fuels data with the LANDFIRE Total Fuel Change tool, you're going to want to get these fuel veg layers. In the past, you would have grabbed existing vegetation type, cover, and height, but now you'll get the fuel veg type, cover, and height, and those will work well with the rule sets in the change tool that classify the data into the fire behavior fuel models layers. We have been working since 2015 on a review and improvement of the LANDFIRE biophysical settings models and descriptions. What that product is first of all a qualitative description, and then a quantitative model describing pre-European American vegetation structure, composition, and disturbance dynamics. During this review, we worked with experts to update the models with new science. We worked to complete and improve our succession class mapping rule set. That's important because in the past, that rule set, it wasn't complete. It had some gaps, and it also had overlaps, which made it really difficult to map. Now we've got a complete rule set. We've resolved all the issues, and what that's going to do is improve our measurement of vegetation departure, because succession class is an input into calculating vegetation departure. We also have new model description documents that we'll be delivering, and these documents include the succession class mapping rules and all the state and transition modeling parameters. You don't have to go into the modeling software to understand the information contained in that. You can go right to a Microsoft Word document. And finally, we have a new model delivery website that we've developed. The review in the Northwest I consider to be a big success because of all the input we had from local collaborators. We had tremendous participation from the U.S. Forest Service ecologists, Nature Conservancy ecologists, and BLM ecologists in the region. You can see in this map in the dark blue the geographic extent of the biophysical settings that were reviewed. We covered almost every major forest type. We missed some of the wetter coastal systems in particular, but we got most of the major forest systems. We also reviewed and improved all of the major sagebrush types. An area of deficit that I think jumps out on this map is that we didn't get a lot of review and input for the non-forest range systems on the Columbia Plateau and in southeast Oregon. So a lot of improvements were made to the models through the review process, and I'm just going to pull out one example from the Northwest to illustrate the types of things that you can expect to see in the revised model set. This example comes from the mixed evergreen forest. That's a major forest type in southwest Oregon and northwest California. Importantly, this type spans a really wide gradient in precipitation and temperature and topography. So in the left column here, you can see that we modeled this one particular forest type using one biophysical settings model for its entire distribution in the first iteration of our models. When we got review, experts told us that we really should split this type into a couple of different variants because it was just covering such a wide range of fire regimes and moisture and temperature gradients. So we decided to split it out into a coastal type to represent areas with more maritime influence and an interior type that's generally found east of the coast range at higher elevations and relatively drier sites. So the two new variants, the coastal and the interior, are shown in the columns on the right-hand side of the screen. And you can see that they have pretty distinct fire regimes. So the coastal type is dominated by mixed severity fire with a 39-year fire return interval. And the interior type is dominated by surface fire with a much more frequent fire return interval. We have a new website where users can access the data. It's searchable and we believe provides a much more user-friendly environment for accessing the model information. The reviewed and updated model data set are complete for the continental US and Hawaii, but they're not yet publicly available. We have allowed people to use them on request and we'll continue to do that until we get them up and available for everyone. The Alaska models are still being finalized because there are some changes to the legend. To wrap up, I just want to cover a couple applications of how these data have been useful in the Northwest. My first example comes from a paper by Ryan Haugo and others. This just came out a few weeks ago in Ecosphere. It's called The Missing Fire: Quantifying Human Exclusion of Wildfire in Pacific Northwest Forests. This study demonstrates how the LANDFIRE biophysical settings models can provide context for answering current land management questions. So in this particular article, the authors tackle the question, has wildfire extent and severity changed over time in Northwest forests? To answer that question, they were able to take current information about fire extent and severity from modeling trends and burn severity data. For the historic information, they looked to the LANDFIRE biophysical settings models. And they took the models and they made a couple of modifications for how the models are run to increase the variability and ran them out to quantify a historical fire extent and severity. And then they compared those two. So it's a great paper. I encourage you to read it. Just briefly, their result was that they found fires today to be less extensive than they were historically, and current fire severities don't align with the historical fire severities. Another example that we've actually seen in the Northwest and other places around the country is the use of LANDFIRE data to support forest plan revision. I've been involved with the effort on the salmon chalice over the last year or so, and this graphic on the screen now illustrates the results of their vegetation departure assessment. They took the LANDFIRE biophysical settings models to quantify the historical conditions and then compared that to the current condition, which they quantified using the LANDFIRE spatial data. And so they get a snapshot of what the current vegetation conditions on their landscape look like today. They've also used LANDFIRE data in other parts of the forest plan revision process. For example, they use the fuels data in a fire risk assessment. All right, to wrap it up here, you can expect LANDFIRE Remap products to look and feel a lot like the previous products that we've delivered. We're still aiming to put out a comprehensive, compatible, consistent, and current suite of data. The 2016 Remap products incorporate new processes and data sets that we think have improved the usability of the products. And as always, we encourage people to provide feedback, and if you have plots and data that we can ingest into our process to produce better products, we always appreciate that. You can provide feedback in a couple of different ways. You can see here on the screen, and again, that feedback can be used to improve subsequent versions of the LANDFIRE products. You can always reach Jim and I via email. And to wrap up, I'll leave us on this screen, which has a lot of different ways you can get in touch and keep informed about what's going on with LANDFIRE. And I'll just wrap up again by thanking the Northwest Fire Consortium for hosting our webinar today. And for all the folks listening in, thank you for taking the time to learn about LANDFIRE Remap, and we'd be happy to take any questions.
Thank you, Corey. And as always, the Northwest Fire Science Consortium is happy to host webinars like this. So we'd like to thank you for coming on and giving this presentation of, it just is a tremendous amount of work that you all do. It's impressive. So let's take some time to think of some questions. Go ahead and type those into the chat box or in the Q&A box, whatever you prefer. I know that some people on this call might be interested to hear, if they haven't already heard about, that the Joint Fire Science has announced its funding opportunities, and that opportunity actually closes next week on May 16th. So get your proposals in. And you know what, I'll go ahead and put a link to their website in the chat box. So let me do that right now. So go ahead, check it out, and get your proposals in by next week. Let's see if any questions have come through. Okay, no questions yet. So while we're waiting for questions, I'll just say that the consortium offers a diversity of opportunities for people to participate in, and hosting webinars like today is just one way we accomplish that. Other opportunities include workshops and field tours and things like that. So thank you again for tuning in. I've got a question here. Is Remap 2016 currently available without the fuel data set?
Carrie, no, the fuels are available. The vegetation products are available for the entire Northwest geo area. But I did want people to know that there are some modifications, some improvements, enhancements to the fuels layers that we accomplished since original delivery. So while they are available, I would encourage people to stay tuned that use the fuels products. That is the Scottenbergen 40, the 14, the Canopy fuels. If you use those products, we are going to be replacing what we've already delivered pretty soon with a new enhanced product. So they are available, but stay tuned.
Great. Thank you, Jim. And just a nice note here to the LANDFIRE team, just a note from a participant, great job, LANDFIRE team. So I just wanted to pass that along. Is there a plan for verifying, I lost the question, let me scroll down again. Sorry about that. My window for looking at these questions is really small. Is this compatible with Google Maps?
These files are not directly, what I'd say, they're not KML files. So they have to go through some work to actually display them in Google Earth with Google Earth data sets. These are delivered as arc grids. All the spatial products are delivered as arc grids, not as KML.
Got it. And then is there a plan for verifying the rest of the Northwest? And they write in a parentheses, thinking of that light blue, dark blue map that you presented.
Well, I would say what we hope, and Corey can weigh in as needed, is what we're going to try to create is a continuous review and improvement process for the biophysical settings models and descriptions. We basically own that product as a part of the LANDFIRE program. So we want to create it where we can continually ask for feedback, try to fill those holes as best we can by making it easy, let's say, as easy as possible for someone to obtain what we have, make reviews, submit it back to us. So rather than this once a decade update like we've done this time, we want it to be a continuous improvement product, and we are working to modify our systems to allow that, but they're not there yet. But hopefully maybe within this calendar year, we'll be able to institute that review process to fill those light blue holes and make them dark blue.
Excellent.
I'll just add to what Jim said. The biophysical settings, models, and descriptions are a very unique LANDFIRE product, not only because they're not spatial, but because they're really generated by the user community. We don't create them. We just try to wrangle people into helping us make them. We're a small team. You saw us in one of Jim's first slide, and we seek out experts in these systems around the country to provide input because we don't have the knowledge ourselves. And so what you see in that map that I showed of reviewed and non-reviewed systems, that's really a reflection of who we were able to get input from. And we just were not able to get as much input into the non-forest systems. But we did put a great amount of effort into it, and we will continue to do that.
Great, thank you, Corey. And are you still incorporating current CFI plot data being forwarded to your shop from tribal organizations?
I don't know if Jim's on mute. He may have a better idea of that. I'm not familiar with that particular plot data. Jim, are you there?
Yeah, I'm here, and we incorporated those plots into the LANDFIRE reference database, what we call LFRDB. So if they met the quality criteria, they're geo-referenced, they had the information that's required for the AutoKey process or for the assignment process, they were used in the remap. Now, the confusion has been plots are not directly used thus far in an update. So they were not used in an 8, 10, 12, or 14 update, except for assessing quality or using as a way to look as just sort of an ancillary data set. But they were directly a part of the mapping process in Remap if they met the quality standards that LANDFIRE requires.
Mm-hmm. We are currently using BPS. This is a question coming in. We are currently using BPS to divide the landscape into major three physiognomic groups. What kind of accuracy can we expect to have for the non-forest physiognomic types, knowing the amount of feedback you have had on those types?
So it sounds like the participant is using the spatial biophysical settings grid, and that's different than the BPS models. They're related, but the information I presented about review of biophysical settings models doesn't apply to the mapping of the spatial biophysical settings data. So if I understand the question correctly, the participant's asking about the accuracy of the biophysical settings spatial data, and we don't have a way to assess that with existing vegetation type. Of course, you're comparing to plot data because we can gather plot data for that. We have no way of, we don't have reference points for the biophysical settings concept. So there is no accuracy assessment of that.
Yeah, and I would add that there has been some sort of ad hoc empirical information on a sketchy basis from some places, but it's not to the level where we could say write a report and say here's how accurate the spatial data is, how well it reflects the actual true biophysical setting. But I think if you're using it in a general categorical way, then it probably represents that fairly well. But remember that LANDFIRE is not a cleaned up data set. It is a data set that's delivered as its output. It is intended as regional national data. So you're probably going to find some oddities in there, would be my opinion. You'll find some speckles, some single pixels that are odd. You'll find things like that in a data set like this. So you might need to clean those kinds of things up. But if you're classifying the landscape in a general way, then you're probably doing pretty well. I can't put a number on it because I don't know what the classes are. But you're probably doing a pretty good job of general classification of the landscape.
Also, if that person who asked that question wants to reach out to us via email, we could take a closer look at the actual data. It sounds like an interesting question.
Yeah, thanks, Corey. So Corey and Jim, I apologize. I don't know what the next question's abbreviations are, so I'm just going to read the question as is. In the LF, EVT, PNW, there's substantial areas mapped as recently logged -tree cover. Best LF layers / procedures for identifying ecological systems and disturbance areas?
Okay, so I believe that I can understand most of that. So
okay, great.
I believe so. LFEVT means the LANDFIRE existing vegetation type product, and there is a category in there for a recently disturbed area that might be called recently logged, okay, or recently disturbed or something like that. So I'm not sure what the question was related to. It said best LF something. I didn't catch that. What was the rest of that?
Yeah, so best LF layers / procedures for identifying ecological systems in disturbance areas.
Okay, so
sorry, go ahead, Jim.
Go ahead, Corey.
I was just going to say it sounds like maybe they want to identify the underlying ecological system.
Right, that would occur there. So what LANDFIRE would do is they would, once that has transitioned from what they would call recently logged to something that's revegetating, they would apply a rule to that that says the previous EVT that was disturbed to this severity would become the new EVT, okay? And those rules that LANDFIRE would use are available for download on the LANDFIRE website. It's called the Transition Database. So LANDFIRE just didn't think it had progressed far enough in the revegetation stage to establish a new ecological system. But you could see the rule that we would use if it had reached that. So that's probably what you would use. Now, in many cases, that the previous ecological system, LANDFIRE would reestablish it in the disturbed area at some point, unless the disturbance was just of a very high severity or in some unusual condition or type. Then they might actually change the system. But mostly, I believe, we will place the original system back in that pixel once enough time has passed. I hope that answers the question. If it doesn't, please reach out to me and I will help you try to identify the correct answer, okay? Whoever asked that question, you can contact me directly.
Thank you for that, Jim. We've got another question here. Where can we get the actual latest remap, Southwest Scott Bergen fuels? I cannot find them in the LANDFIRE data distribution site. Thanks.
Okay. I thought they were there, so you'll have to let me check, because if they're not there, I consider that to be an error, because it should be there. And I will check, and if you'll either let Carrie know your email address or contact me, jim_smith@tnc.org, I will find out what's going on and make sure you can get that data. But I'll have to check, because I thought it was there.
Okay, great. I'm copying down the name, and then I'll pass that along to you.
Okay.
Great. Any other questions, folks? Get them typed now. We have less than 5 minutes here. This has been such a great session, a lot of great information, a lot of good questions. Jim and Corey, you've been wonderful, telling folks to contact you with questions. Do you maybe want to scroll back to your email slide so that people, if they didn't get a chance to copy your emails, there we go, Jim_Smith. Don't make the mistake I did and say Jim.Smith. It's Jim_Smith@tnc.org, and Corey Blankenship, kblankenship@tnc.org. So there you go. There are their email addresses. I don't see any other questions coming in. Are there any final comments or thoughts from Jim or Corey, or Jeannie's online with us also from LANDFIRE?
I'll just thank you again and just reiterate once again that, one of our jobs in the LANDFIRE program is to try to help users use LANDFIRE program products appropriately. Reach out, don't hesitate, either to us directly or send an email to the help desk at landfire.gov, and we will respond as quickly as we can. And we appreciate your time very much.
Great. And just before we lose you all, there is one more question. Is there a way that as a community we can collaborate to the Fuels Plot database? Is there a form we could use? Thanks again.
There is a submission process on the landfire.gov, www.landfire.gov. You'll see an actual topic there called contributing data. And from there, it'll show you the process that you can use to contribute either plot data or disturbance perimeters or feedback or whatever is useful. We would certainly like to hear that. So go to contributed data on landfire.gov and you'll find that process.
Fantastic. So I want to shout out and say thank you all, the participants, for taking your time to tune in to this webinar today. There is a super short survey, and I mean super short, seconds at the end of this webinar that I encourage you to take. The information that you provide helps us to measure the impact from the webinar that you just listened to. As well, it offers an opportunity for you to list future webinars you'd like us to host. So please do take that survey. It literally takes maybe 7 seconds. So thank you all. Have a good rest of your day, and we'll talk to you all soon.
Thank you. Thanks, everyone.
Thank you.
Bye.